while true. And then every time like search for number in X that is the same in Y. Oh, like you have like, so will always be X and X, or can I use X and Y as well? Let's see what yours before. Oh, no. Okay, so this syntax right here, you're defining a new variable. So this could be like Pokemain. Like literally you can define that whatever you want. This keyword, it requires the next one to be a storage or a list. So and so for each time it loops through, it'll define Pokemain. It'll set a new value. So it'll start at 0. So that whenever the loop counter starts at 0, Pokemain will equal 5. And then when it goes to 1, Pokemain will equal 10. And then 2, 15, blah, blah, blah. He searches. Okay, second one will define less. He searches in. Yeah. X being a set of numbers. So for your example, I think it would be Y for Y and X. I'm pretty sure that would be your example. Would be for Y and X. But really the thing to notice about this is just you're defining a variable and you're looping over a collection of data pretty much. And this condition, this for condition, it will stop when it reaches the last element. And like this No, definitely not. Most of the time, in programming, you definitely, actually, I don't even know if you definitely can redefine a variable like that, but this is always what's called a temporary variable. Like Pokemain does not, like in computer memory, Pokemain does not exist after this for loop. It will pretty much be it's what's called a temporary variable. So it only exists for a very short amount of time. And usually whenever you have a loop, you have some type of operation where you need that temporary variable just for whatever you're doing, and you don't want to hold on to that information. You don't want to waste space. So loops are usually for each loops are always using a temporary variable and doing something with it. And then it's iterating always over a collection of items, usually in an array list. It's too early on to get into other collections and data types, but that's definitely the best way to look at this is just this right here, this for, after this keyword is the temporary variable, and this n, after n, you have to declare which array list or collection you're using, and it just prints it to the screen. So yeah. If you place another value, it won't collide. Yeah, okay, I'll show you. Hold up. So this should give me actually an error. It definitely, I think it I'm pretty sure it will. Let's see. Oh, no, it didn't. Okay. Huh. Wow. Well, yeah, okay, so I guess it just stores. I thought after it got out of scope, it would that would be set back to or it would be undefined. But I guess Pokemain keeps the last value of the array list at the end. But if we do this, then see what happens then. Yeah. Yeah, that's it. You're right. It is. It's saving it. I thought. I thought. Like this is what's called like scope. I thought after it left scope, it would automatically um, garbage collect Pokimane. But I guess. But that makes sense. You know. I guess. Makes some sense. Thanks. No problem, homie. No problem. Anytime. 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 Um, all right. Now we're gonna do booleans. This will be quick. But the whenever you use a while loop, I'll go over this just to make this point clear. You always want to have a base condition and other possible outcomes. So this while true, this is something that will always continuously, this is what could be, if you don't follow this guideline for like a while loop, you could run into what's called an infinite loop, which means, I'll write one here in a second. It's the program will never exit, and it's just going to keep running and running, and your computer's going to get hot, and you know, it's, but this base condition, that's your sign to break from the loop. And other possible outcomes, that's the sign to do an operation. So I'll do a really quick one. All right, we're getting a little ahead of ourselves, but this would be a good example of a while loop. Oh wow, yeah. So it definitely worked. So let's print dating. So Stacy and Chad are dating each other. And if we never set this, right? False. Let's get it hot in here, baby. I equals 0. Let's just see. And so yeah, that's a, as you can see, it looped, I mean, that was, what, not even a second, it looped 10,566 times. That's just basically, I have this, this logic error. Like, whenever you're writing a while loop, you always want to, like, a lot of times, depending on the problem I'm faced with, I'll sit down and I'll actually write like the scenarios out. Yes, yeah, definitely. You need to be extremely careful with while loops. Um, the best way to look at it is you have your base case or your base condition, and for me, that's always when I'll break is my base condition. So um, that's usually if I'm looking for something like if I was opening and reading a file, for example, if if the file was closed, then I would break, or if I was done reading the file, then I would break from the while loop. Otherwise, I would keep going through and doing this. I haven't even went over. Yeah, I'm kind of getting ahead of myself with these. With ifs and else and all of this stuff. I know we weren't doing this in the V tutorial, but just a quick thing for showing, the while statements. Like, I don't think you'll probably never run into an infinite loop for a for each statement. I don't know if that's even possible. But usually, whenever people run into like an infinite loop, it's always this while true, it's usually this, usually that. This is actually a decent example. Also, my actually, always how I always pretty much lay out my while. This font's too big, man. Yeah, there we go. I always lay out my while loops in the case where my first base condition is when it will break. My other possible conditions are these if-else statements, where I'll be doing whatever operation needs to be done. And then this last else statement, that's usually when something goes extremely wrong and I need to exit my program, and then I'll usually like do I mean, if it was in C, then I would print the error code to the console and see what was going wrong or anything like that. But I mean, this is kind of like how it is in mathematics. It's like your base condition, the other possible outcomes. This is like the section where you're doing your proof technique, and then your error condition. This is kind of like either you're going to reach your base condition, which means your hypothesis is pretty much accepted, or you'll reach your error condition, which means that you ran into some type of logical error, or there's some bug, and you would have to redo your experiment, pretty much. These are ones you have to be careful with, for sure. For sure. Yeah, for loops are gonna cycle through your collection of data once, and a while loop, it's it's gonna keep running a loop and doing operations until it is told to break. That's it's the easiest way to look at it. There's also do while loops. I'm not a huge fan of do while loops. Some people get into them. I, I, I'll show them some other time. I always stick with this. This is pretty much the format I prefer. Do while, to me, it just seems awkward and weird, but some people like them. Some people like do whiles. But all right, so that's some basic looping. We're gonna all right, so Chad, he's single right now, so he's available. He's on Tinder and stuff, and then Stacy, she's had a long-term boyfriend. She's in a relationship. She's you know, she's unavailable right now, pretty much. This is compared to V. Again, V's lowercase for some reason. I guess that's fine. But yeah, the keyword in V, it's in lowercase. In Python, it's in uppercase. So, quick things. Can they date equals so yeah, Python 3 basics. So no, they cannot date. Stacy's just off the market. You know, Stacy's dating someone. She can't date Chad. Not right now, at least. Will Chad try? Which equals single does not equal. So Chad's still going to try for sure. Again, this is the not equals operator, so just false equal true, no. But if you are looking for the opposite of that, it is true. So can they date? No. Will Chad try? Yes. Yeah, those are the. Also in Booleans you have, we went over these earlier, less than, greater than, less than or equal to, greater than or equal to. All right, so so is it legal? So girl age, oh no, insert, is greater than 18 and boy age is greater than 8. Oh shoot. So it's definitely legal in probably every state in America for them to date. Thanks, appreciate it. Grant. Is he older? Is boy age greater than girl age? Is he older? And I'll do one last one. Is she younger? Is girl age less than boy age? Yeah, so it's Chad's older than her. Stacy's younger than him, and you know, if they were to date, it would be legal technically. But obviously, Stacy's in a relationship. She's happy, so they're not gonna date. But Chad is still gonna try. But yeah, how does it know if it's true or false statements? Okay. So right here, this is how you'll define if it's a Boolean, right? But down here, it's comparing these two numbers, and there's only two possible outcomes for this. It's either equal or not. And if it is equal, it will give it a true value. And if it's not equal, it'll give it the false value. So these operations right here, they're used for comparing numbers. And even you can even compare strings. What do we call it? Oh, there's girl equal boy, which I think this works in Python, and most other languages you have to do something different to compare a string. So yeah. So this works for all the basic data types. These operations right here, greater than or equal to. Mostly those are used for floats and ints. We can talk about overriding, like whenever we get into objects, we can